Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 9, question number 10 and question number 11. Exercise 3B Machines ICSE 10th Physics. The previous questions have been done in the previous videos, the link for which will be provided in the description. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 9th question, figure shows a block and tackle system of pulleys used to lift a load. So as we can see here, there are 4 pulleys. So straight away I can write here velocity ratio of the system will be equal to 4. How many strands of tackle are supporting the load? So let's count one by one. So yeah, so from below pulley number 2 it starts and it goes towards pulley number 3. So there's going to be one tension over here. So that's going to be the first tension here. And then it goes around pulley number 3 and goes to pulley number 2. So there will be the second tension which will be acting here. So that would be the tension here. Then from pulley number 2 it goes towards pulley number 4. So the third tension is going to act over here. So this is the third one. Now from pulley number 4 it goes towards pulley number 1. So the fourth tension is going to act here. And there is going to be one more tension that's going to be acting right here, but this tension will be equal to the effort. So we'll be counting only 4 out of all the 5 tensions. So how many strands of tackle are supporting the load? Our answer for this is going to be 4. Now we are done with the A part. Going with the B part, draw arrows to represent tension T in each thread. I've already drawn that. Getting into the third part, that is, what is the mechanical advantage of the system? Now we know the formula for mechanical advantage. Mechanical advantage is equal to load divided by effort. Now load is supposed to be all the tensions that are acting except the tension for the effort. So we just count the number of efforts here. So the number of efforts happens to be 4. So 4t divided by t. T and t cancels. So we get the value of mechanical advantage as 4. So the mechanical advantage happens to be 4. Now coming to the D part of the question, when load is pulled up by a distance of 1 meter. So what is given over here is dl is equal to 1 meter. How far does the effort move? So we need to find the value of dE. dE we are supposed to find out. So for this we would be using the velocity ratio formula, that is velocity ratio is equal to dE by dl. So this happens to be dE divided by dl. So we just substitute the values. Velocity ratio I've already written it as 4 is equal to dE we are supposed to find out divided by dl is 1 meter. So dE is equal to 4 into 1, that is 4 meter. So distance moved by the effort happens to be 4 meters. Now we have only one part of this question left, that is the E part. So for doing the E part, how much effort is needed to lift a load of 100 newtons? So we'll be using the formula for mechanical advantage again, the same formula that happens to be load divided by effort. Now the load is given as 100 newtons and mechanical advantage we got it in part C as 4. So 4 will be equal to load is 100 newtons, so that is 100 divided by effort, we are supposed to write it as E. So the effort happens to be 100 divided by 4. So the effort is 25 newtons. So the effort we have got here is 25 newton. Now this is the major advantage of block and tackle system. by applying an effort of just 25 newtons, we are able to lift a load of 100 newtons. So I hope this question is clear. Getting to the next question. A block and tackle system has velocity ratio 3. So I would be writing the value of VR here. Velocity ratio is equal to 3. Draw a label diagram of the system indicating the points of application and direction of load and effort. So I've got the diagram here. The load is definitely going to act in the downward direction. So we can, put in an arrow here. So this is the direction of the load, that is downward, and the direction of effort is shown in the figure itself. Now, a man can exert a pull of 200 kgf. That means exert a pull means it's the effort that is given in the question, that is 200 kgf. If I convert that to newtons, we multiply by 10, that happens to be 2000 newtons. We can do it in kgf also, it's your choice. So what is the maximum load he can raise with the pulley system if efficiency is 60%? So efficiency that is given as 60% can be written as 0.6. So for doing the first part of the question, we will be finding the mechanical advantage. Now we know the formula for efficiency as mechanical advantage divided by velocity ratio. So mechanical advantage will happen to be efficiency into velocity ratio. So we just substitute the values here. So mechanical advantage happens to be efficiency is 0.6 into velocity ratio is 3. So we get the value of mechanical advantage to be 1.8. So the mechanical advantage is 1.8. Now we need to find the value of load. Effort is already there in the question. So we know another formula for mechanical advantage, that happens to be MA is equal to load divided by effort. So pretty simple here, we just need to substitute the values. So load will happen to be mechanical advantage into effort. So load happens to be mechanical advantage is 1.8 into effort. So effort we just got it as 2000. So we get the load as 3600. 18 into 2 is 36. So 3600 newtons, or if we wish to write it in kgf, it's going to be equal to, we need to divide it by 10. So 3600 divided by 10 is 360 kgf. So we just got the load as 360 kgf. So we are done with the A part of the question. Now going into the B part, if the effort end moves distance of 60 centimeter, so DE is given as 60 centimeter, which is 0.6 meters. What distance does the load move? So for doing this question, we will be using the velocity ratio formula, which happens to be dE by dL. dE divided by dL. So I just substitute the values. Velocity ratio we have got it as 3. So we need to find the value of dL. So dL will be equal to dE divided by velocity ratio. So dL will be equal to dE is 0.6 divided by velocity ratio is 3. So in order to remove the decimal, we multiply numerator and denominator by 10. So we get the value of dl as 6 divided by 30. So dl can be written as 1 divided by 5, or dl happens to be 0. 0.2, yeah, 0.2 meters, or we can write it as 20 centimeters. So this completes the B part of the question. Now getting into the next question, you are given 4 pulleys and 3 strings. So whenever there is 4 pulleys and 3 strings, we should understand that the system has to be one fixed pulley and rest all movable pulleys. Draw a neat label diagram to use them so that you can obtain maximum mechanical advantage. So please remember, when we have one fixed pulley and rest movable pulleys, we basically obtain maximum mechanical advantage, and it is given as equal to 8. So the mechanical advantage is supposed to be equal to 8. In your diagram, draw the directions of load, effort and tension in each strand. So the diagram, I have just drawn it here. I've just got it here actually. So you can see here there are 4 pulleys, A, B, C and D. So that completes our requirement of 4 pulleys and 3 strings. So the first string is going from the rigid support and till the pulley B through pulley A. The second string is going from the rigid support through the pulley B till pulley C, and then the third string is going through the pulley C and passing through the fixed pulley, that is D. So this completes our requirement of 3 strings also. So in your diagram, mark the directions of load, effort and tension in each strand. So the tension and the load and the effort, everything is marked. The effort is right over here. This is the effort, and the load is written down here. So that's going to be the load here. So what assumptions have you made to obtain the required mechanical advantage? So assumption is 3 movable pulleys with 1 fixed pulley, so that is what we are supposed to do, and the assumptions remains to be the same for all the machines problems, actually most of the machines problems. So the assumptions are going to be, the first one, efficiency is equal to 100%. Then the second one, no frictional loss, and the third one, massless pulleys. So these are the assumptions which we actually consider. Just to show you the mechanical advantage, I can use the formula, that is mechanical advantage is equal to 2 to the power of n. Now n happens to be the number of movable pulleys, so that's going to be 3, that is A, B and C. So here it's going to be 2 to the power of 3. So 2 to the power of 3 is nothing but 8. That is what is given in our question. So this completes this particular exercise, that is exercise 3B, and it completes the machine chapter also. If you like the video, do share it with your friends and consider subscribing to the channel. See you guys in the next video in some other chapter. Till then, Dhanyavad.